Hello and welcome on this video on the topic of Industry 4.0 and digital twinning. My name is Maaike Slot. I'm a research engineer at the Fraunhofer Project Center at the University of Twente, and today I'm going to tell you more about where do you start when you want to implement digital twinning and Industry 4.0. So before I start off, I want to tell you that case studies and examples are drawn from our experience and activities working from a variety of customers across multiple projects, and they do not represent our work for any one customer or set of customers. In many cases, facts have been changed to obscure the identity of our customers and individuals associated with our customers. So, Industry 4.0, what is it? I can imagine that you have the question, why should I invest into Industry 4.0? What will it bring and how can I implement it in my company? How does it even look and what is it? In the coming 10 minutes, I will try to explain to you the basic concept of Industry 4.0 and how we can use the digitalization in our advantage with the use of digital twinning. So, Industry 4.0, what is it and how does it affect us? We made the steps to Industry 4.0 from factories to automation. That was the first part and the introduction of the digitalization of a factory, because we needed to actually know what those automation aspects of our factory were doing. So we started adding sensor technology. And because we also wanted to control the technology that we implemented in our factory, we had to build systems that were able to allow us to communicate with those systems. And Industry 4.0, in my opinion, is the next step, where we say, okay, now we can also let the automated parts of our factory communicate with each other. So digitalization in Industry 4.0 entails the step from our basic factory until the part where we say every part of our factory is interconnected and can communicate. Not everything needs to be communicating with each other, but I think if you start making those steps in your factory, you will reach the level of Industry 4.0. So what if you could measure everything? I'm very interested in knowing your ideas, so please also send them to me if you have an idea of what you would actually like to measure. I certainly wouldn't like to measure everything, and I'll tell you why. I think of all of the money that you need to spend on storage and data storage centers, and the space you need for that. Next to that, have you ever tried to find a needle in a haystack? Don't overdo it and don't take it a step too far. One of the most important things is that we should be able to communicate about our data in an understandable way. We need to be able to put the data in its context, either doing that through tables, graphs, or data visualizations, or by means of digital twinnings, which I will be telling you about in just a bit. But just make sure you prevent yourself from being the guy on the stage presenting bigger data, or finding yourself in a room with people saying, let's use big data to solve the problem. Because most of the time you don't even know what the data means. And if you don't know what context the data has, you can't use it to transfer it to knowledge. So enough of talk about big data for now. I want to introduce you to the basics of a digital twin. So what is a digital twin? There are many definitions and explanations that have been written over the past years. It goes from digital shadow to a 3D model. I even heard someone explain it as a digital Excel sheet. But in my definition, it's an ever-evolving digital representation, which means a conglomerate of data, information, models, tools, and techniques of a physical asset. But maybe that's a bit of a too complex way of explaining it. The ever-evolving means that it needs to be updated to represent the real-time situation, and that the digital twin is a never-ending product. It needs to keep on improving itself as well to follow the physical asset. And the definition of Reeves might speak more to the imagination, where he says that the digital twin is a conceptual model underlying the product lifecycle management. So following every bits and steps of the product through its lifecycle. So what can a digital twin actually do? A digital twin is mostly used now for visualization, and not only visualization of basic data, but mostly of complex information. So where it can be very difficult to correlate different data to each other when you look at an Excel sheet, a digital twin is able to put it in its context. It can give you insight in your production environment because you can look at those different levels of aggregation throughout your production environment. This allows you to get insight and link data to each other in a more visual way. Next to that, one of the main benefits of digital twinning is that if you have it set up, you can use it for what-if analysis. Meaning, what if I would change the speed of my factory to 120% of what it is now? What would actually happen? So without actually having to damage your machines or trying it on your real production environment with the risk of damaging your systems and the breakdown, you can do this in a digital version because you have a digital representation of your physical assets. So that's what if analysis. It also is used for prototyping in production environments. What if we would add an additional machine? What would actually happen? This prevents you from spending a lot of money already and investing in something that if you tested it through the digital twin, you would have known that it wouldn't work. So not only is it used for prototyping and what-if analysis, but it can also help you to simulate and optimize your production. So there are certain fields of application for a digital twin. It's not limited to these, but I think this is a good way of explaining where it is used. So it can be used from the first part of the production of a part, design of a product, the actual production in field, the future product, and the maintenance part. So it's from design, production, to actually the usage of a product or a machine to incorporate all of that data into your future product and also use it to look, for example, on predictive maintenance. I understand that many companies have the question, how do I prepare my company for a digital twin? And I always start off by explaining that, unfortunately, there is not a digital twin that can read your mind yet. The same goes for a developer or an engineer. When you ask them to look at a solution or develop something, they can't read your mind. So with them, you always start by saying, okay, let's look at what we actually want to do and what questions we want to have answered. So actually, the first step for realizing a digital twin, it's gathering your stakeholders and the people that need to start working with it, finding the underlying goal, and discussing, okay, if we could have had a magic stick, what would we want it to do? And from that point, you can look at realistic steps and cut them up in smaller pieces so you can start actually realizing a digital twin. So when you understand with each other and you have a common understanding and you know what questions you want to have answered and where you want the digital twin to support you, then you can start gathering the right data. Most of the time you already have bits and chunks of data, but you will probably have to add additional sensor technology. Don't overdo it, as I said at the beginning of the presentation, but gather the right information and the right amount. It's never a bad idea to gather more, but make sure you separate the really necessary data with the proven correlations from the data that you're going to use for research into new correlations, because those correlations are not proven and validated by yourself, so they can also give you wrong information. So make sure you separate them from each other, and you also prevent yourself from trying to find that needle. So if you have the gathered data and you have the goal you want the digital twin to achieve, go and look at how the data actually needs to be represented. This means that for every stakeholder, there's actually a different way that the user would like to see the data. So it's actually a big challenge, and I think that's digital twinning can help in that, is getting the right data to the right user in the right context. meaning that an engineer on your shop floor might want to see an actual 3D model and the data in its context of the usage of, for example, an engine on an iPad or on his phone, where your production planner wants to have the data of the complete production floor and all of the lead times, and your contract manager would like to only see the time that it takes to pass through a complete factory and look at optimization of the contract that's being made. So they all need a different way of representing the data, and they also all need different data. So make sure you look at that. And if you follow those 3 steps, you should be able to start with your first digital twin. Following these will also make sure that you get digital twin that is tuned to actually what your needs are. So I want to thank you for your time, and I hope you have learned something in this video. If there's any questions or you need help with the following steps that I explained, please don't hesitate to contact me.